Hello everyone, we would like to present to you our topic, which is volumetric analysis, determination of concentration in acid-base solution. First of all, I would like to introduce you to our group members. We have Alson Julius, Siti Rabiatul, Eva Natasha, Marcelina, and Cassandra. For those who doesn't know, volumetric analysis, also known as stoichiometric, is a quantitative analytical method used to determine the concentration of a solution by reacting it with a standard solution of known concentration. One of the most common applications of volumetric analysis is the determination of the concentration of acids and bases through a process known as titration. The precision and accuracy of titration depends on proper technique, careful measurement, and the correct choice of indicator. This method is widely used in various fields, including environmental testing, pharmaceuticals, and food chemistry, to ensure quality and compliance with standards. Next, the objective of titration is to determine the concentration by reacting it with a solution that the concentration is known. This is achieved by solution until the reaction reaches a specific point, which can be detected by color changes, pH changes, and any other measurable property. These are some of the basic components of titration. We have indicator, burette, titrant, Erlenmeyer flask, analyte, pipette, and magnetic stirrer. And this is the example of titration and its successful result.
Application of titration. Acid-base volumetric analysis is widely applied in various fields where accurate chemical concentration measurements are essential.
Contribution. In food industry, it used to measure the acidity of food like vinegar and dairy product. In pharmaceutical industry, to determine the right dosing for a person to prevent toxicity and side effect. In water testing, to measure water supply to public meet standard pH and check presence of contamination like chlorine. The theory behind acid-base titration is based on neutralization, where an acid reacts with the base to form salt and water. The titration continues until the reaction reaches the equivalent point, where the number of mole of acid equals the number of mole of base. This is usually indicated by a color change of the indicator, such as phenolphthalein turning from colorless to pink in a basic solution. The formula is used: Ma times Va equal to Mb times Vb, where Ma is molarity of acid, Va volume of acid, Mb molarity of base, and Vb volume of base.
Next, we move to methodology of the determination of percent content of acetic acid in vinegar. Vinegar is a diluted acetic acid. Commercial vinegar should contain about 4 to 6% of acetic acid. The acetic acid contained in vinegar can therefore be determined through titration method using a standard solution of a base, for example, NaOH. In this experiment, the acetic acid content in different brands of commercial vinegar is to be determined by titrating them with sodium hydroxide. Objective and apparatus. The objective of the experiment is to determine the content percent of acetic acid in vinegar. The apparatus, we have 250 ml volumetric flask, retort stand, white tile, 250 ml conical flask, 20 ml pipette, and burette. The chemical reagents, we have 3 brands of commercial vinegar, NaOH pellet, and phenolphthalein indicator.
Next, we go to the procedure. For a preparation of NaOH solution and standardization of NaOH. First, the mass needed was calculated to prepare 250 ml of 0.1 molarity NaOH solution. Second, the NaOH solution was prepared using the same procedure as in experiment 2, preparation of solution. Third, the burette was then filled with NaOH solution. Fourth, 20 ml of the HCl from experiment 3 was pipetted into 250 ml conical flask. 2 to 3 drops of phenolphthalein were added as an indicator. Fifth, the HCl was titrated in the conical flask with the NaOH from the burette slowly while shaking the flask until the indicator color change. The color changes and the reading was recorded at the end point of the titration. Sixth, it was then repeated 2 to 3 times and all the readings was recorded in a table. Last but not least, the exact molarity of the NaOH solution was calculated. For B, determination of acetic acid in vinegar. First, 10 ml of the given vinegar, the brand name of the chosen vinegar was recorded. It was pipetted and diluted to mark with distilled water in a 100 ml volumetric flask. Second, 20 ml of this diluted vinegar solution was then pipetted into a 250 ml conical flask. 2 to 3 drops of phenolphthalein were added as an indicator. Third, the vinegar was titrated in the conical flask with the NaOH from the burette slowly while shaking the flask until the indicator changes color. Fourth, step 2 and 3 was repeated 2 more times. Fifth, the reading was recorded at the end point of the titration. And last but not least, the weight over volume percent of acetic acid in the vinegar sample was then calculated. Next, we go to the result and calculation. For the result of standardization of NaOH solution, the final burette reading for rough titration is 18.1 ml, while the initial burette reading is 0 ml. Therefore, the volume of NaOH used is 18.1 ml. This goes same to titration 1 and titration 3. Meanwhile, titration 2 final burette reading is 36.1 ml and the initial burette reading is 18.1 ml. Therefore, the volume of NaOH used for titration 2 is 18 ml. The average volume of NaOH is 18 ml, and the exact molarity of HCl solution from experiment 3 is 12.08 molarity. For B, determination of acetic acid in vinegar, the brand of vinegar used is HW Cap Ayam artificial vinegar. To calculate the percent weight over volume of acetic acid in the vinegar sample, first of all we need to calculate the mass of acetic acid, which is moles times molecular weight. The moles is 0.1136 mole times 60 gram per mole. The mass of acetic acid is 6.816 gram. Second, to find the percent weight over volume of acetic acid in the vinegar sample is mass of acetic acid over volume of sample times 100. The mass of acetic acid is 6.816 gram over 100 ml times 100. Therefore, the percent weight over volume of acetic acid in the vinegar sample is 6.816%.
So, let's move on to the precaution steps in titration. So first, clean glassware. You must ensure that all glassware used in the titration is clean and free from any contaminants. Second, accurate measurement. Use a calibrated glassware for accurate measurement of solution such as pipettes, burettes, and also volumetric flasks. Next, indicator choice. Choose an appropriate indicator for the titration based on the pH range of the reaction being studied.
4. Remove air bubbles. You must ensure that there are no air bubbles trapped, especially at the tip of the burette. Next, the titration speed. Control the rate of the addition of the titrant to avoid overshooting the endpoint of the titration. Then, reading at eye level. Read the volume markings on the burette at eye level to minimize parallax error. Last but not least, repeat for accuracy. It is important for us to repeat the experiment at least 3 titrations and take the average of consistent result.
Finally, in conclusion, this experiment helped us understand how to use titration to find out how much acid is in vinegar. We used a base called sodium hydroxide and added it slowly to the vinegar until we saw a color change using an indicator called phenolphthalein. This color change showed us when the reaction was complete. From that, we calculated the percentage of acetic acid in the vinegar. Titration is a useful and accurate method that is not only important in the lab but also in real life. It is used in the food industry to check acidity in the medical field to prepare the right dosage of medicines, and in environmental testing to make sure water is safe to use. Overall, this experiment taught us how to be more careful and precise in the lab, which is very important for everyone working in science or chemistry.